Hey FreeCAD people, today's topic is about object tessellation in the 3D space in FreeCAD and why you should not use it as a reference for making other geometry, because the tessellation is a little bit unreliable. So this person asked a fair question. If I make a 50mm radius cylinder, why is it not actually 100mm diameter? Why would it have different values when sketched upon, say 50mm on one side and 49.9 something something on the other side? Fair question. Basically, you're referring to an imperfect representation of an idea. If you take a circle and really break the reference sphere that humanity has made, if you break it down into atoms, you still have at some point a rough surface. So these 3D objects are represented by a bunch of triangles, a lot like a video game. And you want as many triangles to represent your surface as you can, but you also don't want to spend forever on processing, because then it's going to be choppy, so you have to strike a balance. And the balance here is that you can kind of see it. If you slowly rotate through, you'll see these sort of lumps on the surface, and you can make it more refined by going to the body in question and changing the deviation to the smallest value is 0.01. I don't recommend 0.01. On big objects it takes way too long to process, but it's fine. The surface quality is very fine indeed. But let's change it back to what it was, 0.2, and reproduce this person's problem. And I can see that there's a sketch with 2 construction lines in it and some width constraints, and there's no expression on this constraint. It's just this person has a lot of visual acuity, and they're basing this number that they set off of what they can see. Now if I change the body deviation, what's going on here? Yeah, okay. If I change body deviation to the smallest value, we can observe that now there's a mismatch. This surface is over here, whereas it used to be, a bit over. Let's change it to something else, say 0.5. Whoa, now it's in another spot, but the edge distance goes to the correct place. You can either do one of two things. You can use the projection geometry tool and get something that is, we'll go into reference mode here. You can get a value based on that, and you can see that it's indeed 50, like you'd expect. But if you want to set something, instead I'd use expressions. So if you go to the expression editor, we can refer to the cylinder simply by its label. Start typing cylinder. You either get the internal name or with the label. And I prefer using the label method because it'll update when you change the label, and it's more descriptive. So you have the cylinder one, and type in radius, and you get it as a actual value. And if it still looks mismatched, right? It still looks weird. But if you change the value to say 55, and I'll hit enter, the geometry, the physical 3D object updates, and so does the driving constraint. I think that the use of expressions is a just more durable way of doing things. In my experience, I've been doing this a while in terms of complex references and durable models that don't break. The expressions can be taken to an insane degree, really. There's even instructions for how to do like nested programming, if you will, by way of ternary. I've gone too far. There's ternary operators. Come on, where is it? Conditional expressions. Here we are. Yep. So you can do single line logic, and the way I've used it, for instance, is to make a suspension fork animation which doesn't necessarily stay on the ground every other iteration. It'll come up in the air, or it'll come down. That has to do with a pitch adjustment that is on a specific node, and it just controls, positioning of all this stuff. There's several instructions of nested ternary operators, and you can do pretty fun stuff, but I wouldn't be able to do it visually. No way. So yeah, in short, don't model necessarily based off what you see, because the value could make things just a little, off. And moreover, don't be afraid to refer to things, and even if things go out of scope, it's just kind of a nag. But just get used to referring to things by labels and by way of data, because this geometric constraint or this representation of your geometric ideals, it's flawed. I mean, you can see edges. If you look very closely, there's a discrete number of edges to this wire, for instance, and that is being reflected in the rest of the surface. And incidentally, to the person who wrote about this issue in the first place, the 0.2 deviation was like the worst value in your case. Any other value would have made a closer representation of what nearly 50 value that you wanted to copy, but it never would have gotten there. No value would have gotten there. So you have to think in terms of instructions. Like all this stuff is visual, but the actual tree is like a series of instructions that cascades. And the further you are down, the branches, you can refer to the roots, essentially. But going off the visual is not reliable. So I hope you found that helpful. This has been Drew Diller of Regular Cycles LLC. Have a good one.